Hi, my name is Marcelo Ruaro. I am a postdoctoral researcher at Pontifical Catholic University of Rio Grande do Sul, PUCRS, in Porto Alegre, Brazil. And currently I am the main developer of the Memphis Many-core Platform. On this video tutorial, I will show step by step how to download and install Memphis in a fresh Ubuntu installation. To do that, I will follow a PDF tutorial available in Memphis website. So you can also download this PDF, watch this video, and install Memphis in your PC and use Memphis to test and evaluate our ideas. So this will be a long tutorial and I will follow every small step necessary to install Memphis. This is a fresh installation of Ubuntu in version 18.004 and I just installed this Ubuntu version and download the Memphis tutorial. So now I will open the tutorial and also open a terminal, and we will follow step by step. So, okay, this is the tutorial. This is the version of Ubuntu that I installed. I selected the normal installation, and now I will follow the step by step. So let's start. So now the first part is install some useful packages. So I will copy these commands here. My user is test. So okay, now I type this new command. Install gcc multilib. Yes. Remember that this is a fresh installation, so for this reason I need to install this useful package in order to allows compile 32 bits application, because this version is a 64 bits operating system. Let's continue. Yes. So after to install this useful package, I will restart my system, my Ubuntu. So after restart the computer, I will follow the next step. So my last step was restart the computer. Now I will install MIPS cross compiler. To do that, first I will create a Memphis directory in my user folder. So in this directory I will put Memphis files. So this is my user folder. Let's follow this step by step here. So let's change by my user, that the name is test. Now I will create the folder named tool Memphis to put some installations files useful for Memphis. I will explain more details in sequence. Now, next step is download MIPS. MIPS you can download from the all Memphis GitHub repository. So let's save the file. Okay, download completed. Now I will unzip the MIPS. Okay, step 4, move this MIPS folder to Memphis. So how you can see, Memphis stores the useful files like MIPS cross-compiler. So let's move MIPS to Memphis, to Memphis folder. I always need to change my user. Next step is set permission for all files inside MIPS folder. Okay, cd. Now let's start edit GAPH-PUCRS, where the first step in editing this file is put the MIPS environment paths. So let's copy this path and put in at the end of the file. Here. Change my user to test. Okay, save. Close GAPH-PUCRS. You can kill this window and open a new terminal, or you can only source the GAPH-PUCRS again. So the tutorial recommends to close it and open a new terminal, but I just source GAPH-PUCRS. With this command, I will enable this path here. So now I suppose that this command is working properly. Yes. So as you can see here, after press tab for 2 times, all MIPS cross-compiler options are executable options are available. Okay, MIPS is already installed. Now let's install the systemc. First, let's download the systemc from GitHub. Save. Okay, download completed. Let's go to the download folder. Extract systemc. Move systemc to Memphis. So now Memphis stores MIPS and systemc. Go to the Memphis directory. Now let's install systemc. This same set of steps are available in the Acelera website, but I put here in order to be more convenient. Let's create this systemc folder in user. So now let's configure systemc installation, but instead using this prefix here, I will change for my local prefix. This prefix here is useful if you are installing systemc from inside our laboratories here in Porto Alegre, Brazil. But if you are a generic user, this red path is not interesting. So I will just change to my local path. That is the same path here. So let's apply this command. Systemc is being configured. So let's make. This will take a while. So make was concluded. Now I will apply this command here. So make install. Okay, systemc is installed. Now I will move to the step 4. And on this step 4, I will configure GAPH-PUCRS for the systemc environment variables. So let's open GAPH-PUCRS. Copy systemc. Make sure to all paths exists. Close GAPH-PUCRS, and you can just put source .bash.rc to apply to your environment variables. So let's test if systemc home is working. Okay, it's working. So now these environment variables are enabled. So systemc was successfully installed. Now the next step is install Questa. However, Questa is only this step is only useful if you have a license. And assuming that this tutorial is generic and you don't have a license, it's fine only to install systemc. Is enough to run Memphis. Questa is more recommended for VHDL simulations. So for this reason, I will jump for the next step, that is the Memphis installation. So only to summarizing, we only set some useful environments, variables. We also installed some useful package, and we also installed MIPS cross compiler and the systemc compiler. MIPS basically is to compile the software, and systemc is to compile the hardware model. So the first step in Memphis installation is go to your user folder and install Git. After that, I will clone Memphis project from GitHub. Okay, so Memphis is cloned to our Memphis folder. Let's check. Yes. So this is I'm inside Memphis folder, and this is the first level directory structure. We have applications where some already developed applications are placed. They are well-known benchmarks. Build environment stores all scripts, basically Python scripts. Docs stores documentations about the software. Hardware stores the hardware models, all hardware components including a Plasma CPU, Hermes NOC, network on chip, network interface that mixes DMI functionalities, structure run memory, and also the top hardware of Memphis. Software stores the kernel running inside each core. Test case is a folder used to store test case if in case you don't have this defined Memphis home environment variable, and tutorials stores PDFs with for example this tutorial here. So let's create the sandbox Memphis, where we will put our test cases files folders. This is the step 4. Remember that you are free to create this folder with our name in a different folder, different path. You just need to reference this our folder in the next step, that is step 4, that defines the environment variables for Memphis home. In this case I will just follow the tutorial and edit GAPH-PUCRS, inserting the Memphis environment variables according to the tutorial. But again, you are free to, I don't know why it is not working in keyboard. You are free to create your own path. You don't need to follow this sandbox Memphis path. Okay. Let's close. Let's close the bash and source bash. Now let's test if Memphis is working. Okay, the Memphis commands are visible for the system according to described here. Memphis all compiles all hardware, software and applications. Memphis app compile only applications. I will explain this command in the sequence, but now I just summarizing it. Memphis debugger opens the graphical debugger. Memphis gen generates the hardware model. Memphis helps teach you how to call and configure and pass arguments for these commands. Memphis run execute a test case, and this is a very specific command to sorting the debug files of Memphis, but this is not interesting for this tutorial and you probably will never use it. So after install Memphis, that is a very fast set of steps. The next step is install Java. So this is very easy, only to follow this command. And after install Java, I will install Python, because Python is the language of all scripts of Memphis. Remember that these scripts are inside the build environment folder. Okay, now install Python, and also I will install the YML station of Python in order to allow Python to open this kind of extension. Okay, now all the basic software components are installed, and let's move to the second part of this tutorial, that is the hardware model generation. We already installed all necessary programs to execute Memphis. Now I will start to model a new many-core system. The most important file necessary for Memphis is a test case file, description file. This file is used by Memphis scripts to generate the hardware according to the specifications that are provided by the user. So the user can set up what is the page size that I want, memory page size that I want, the number of tasks that can run in one individual core, the hardware model description, if it's systemc, VHDL, for example, some NOC buffer size parameter, the many-core dimension, and also the cluster dimension. You can read the description of all these flags here in the tutorial, but some of these flags I will explain during this tutorial. So the first step is to go to your Memphis home, that basically is your sandbox folder, sandbox Memphis home, and create a my test case file. Get it, my test case.ipsum.aml. So this is the test case, and you can just copy this is a very simple hardware model. So this means that this is hardware model. So Ipsum AML requires is indented using spaces, so you need to put some spaces here. I'm inserting 2 spaces. So in this model I want that all core execute only one task per core. The model description is systemc. The NOC buffer size is def is 8. The many-core dimension, it means the number of cores at x and y dimension is 3 by 3, and the cluster dimension is also 3 by 3. This means that the many-core do not have any cluster division. But for instance, if I insert 6 by 6, I will have a many-core with 6 cores at the x-axis, 6 at the y-axis, and each cluster will have a 3 by 3 size. So in total I will have 4 clusters. But let's make a simple example. And this is the peripheral. Memphis currently have only one mandatory peripheral, that is app injector. Basically this peripheral communicates with the system to inject new applications dynamically. So I just indent this document according to here. Here I put 4 spaces, and here 2 more, 6 spaces, here and here. Let's save. I only doing that because Ipsum AML required this kind of indentation. So let's close. So let's see, here is our here inside Sandbox Memphis is our my test case, and this my test case basically describes the hardware features of our module. The next step is called the Memphis gen command, and this command will call the scripts that will compile and generate the hardware. So Memphis gen and the name of your hardware model, that in this case is my test case. So basically what is happening here is the script compiling software and hardware. The red part here is the software compilation, and the green part is hardware compilation. This is a systemc compilation. So after the model is generated, the Memphis should display this message here. Memphis platform was successfully compiled and generated, and this is your path of your test case. So if you see here, now we have the file describing the test case and the test case folder itself. If I enter here, you are able to see this is a copy of Memphis folders, but this copy is made in order to create a self-contained test case. This is useful for a paper and an article where you need several different test cases, and you don't need to manually copy the different test cases. The Memphis basically create a copy of the test case, and you can keep and store this copy if necessary in the future to replicate this experiment. And let's go to the third part of our tutorial, that is creation of a simulation scenario. So only to summarize what we have so far. We have the installation of all software necessary to execute Memphis. We already defined a test case file, and generate the hardware module through the Memphis gen command. So the next step consists in the creation of a simulation scenario. So there is what is the difference between a scenario and a test case? The test case is the hardware module and kernel, basically kernel and hardware, and a scenario also gives the information about the applications that will execute over this test case. In summary, the scenario is a file that describes the application set that will run in the system. So the user can develop it is our application, or can point to applications that is already developed and is present inside the application folder. So let's start going to the Memphis home. cd Memphis home. So now we come back to the previous to the Sandbox Memphis, where the test case and test case folder are put inside. So in this tutorial I also will address how to develop a new application for Memphis. An easy way is point to an existing application inside the application folder of Memphis. But let's go through the steps necessary to develop a new application for Memphis. So the first step is go to the Memphis home. So let's go to the application folder inside my test case. So here this folder is empty because there is no application yet. So let's create a folder called prod.const our intention here is create a simple producer and consumer application with two tasks. Task producer send packets to the consumer, send messages to the consumer task that receive the messages and print it in the output. So the name of the application will be prod.cons. I create the folder. Now let's enter in the prod.cons. So the folder is empty. Let's create the first task. A task in Memphis is represented by a C file, basically a C file. So let's create the task prod. To do that is basically necessary to create the prod.c file. So git prod.c. So this is our prod. Let's insert this code here. This is a C code. This is a simple C code. How you can see here, this is a main function. This includes that are provided by Memphis. This is the message structure used to send message. This is the message length. We use this flag that is message size, but you can specify your all size. Let's assume 50. This 50 means 50 integer spaces, unsigned integer space of 32 bits. And I'm here. This loop initialize the message array, and this loop here send 2000 messages to the, and this is the send function. Sends 2000 messages to the cons task, and after this loop the task is terminated by calling the exit function. Note that exit, send, echo, all these three functions are described in Memphis API, user application API, that will be not addressed here in this tutorial. So I just saved this file. Now I will create the cons task here. And I will do the same for cons task. Let's copy the code. Okay, so how you can see here, also there is a messages variable, and for 2000 times the cons call the receive function that is also described in Memphis syscall API. Sorry. And after receiving the message, this receive is a blocking receive. The message is printed using the echo to print content of the message. After doing that for 2000 times, the cons task also terminates by calling the exit syscall. So let's save here and close the cons file. Now both, you can see here, both tasks are created. And now let's advance to the scenario file creation. So as I told before, a scenario contains the description of the applications, and inside the scenario file you can specify the time that the application will start to execute in the system, and if necessary where the application's tasks will be mapped, specifying the specific address of each core that each task will be assigned. Memphis address the cores following a XI representation. So the first core at the left bottom corner is the core 0x0, and the right core is also in the bottom of the many-core is the core 1x0, and so on. So this is basically a XI representation address of the core of Memphis. Now let's go to Memphis home. Create a scenario file. I will call my scenario as in the here in tutorial, and in this scenario I will also add another application, and this application is already developed inside the applications folder of Memphis. You need to differentiate between the application folder inside your test case. This application folder is created every time that you call Memphis Gen, and the application folder inside the root Memphis directory that is never changed and contains the application that are embedded in Memphis Git project. So I will just copy this content here, and in some seconds I will explain its meaning. Only it's necessary to indent. I usually set 2 spaces of indentation here in order to be more clear to see the scope of each flag. So this is this file basic. My scenario describes the apps. This is mandatory. The first app is a prod.const that you just created. The second app is mpeg, and this mpeg we don't create it. It is already developed and embedded in Memphis root application folder. So just specifying the application name, the Memphis script will try to find by a user-made application called mpeg. If the user not create any kind of application called mpeg, the script will at second search in the root main application folder of Memphis, and the script will get the mpeg application from the Memphis and not from the user application of inside test case. So basically here you can only define an application Memphis just using this line here, the name and the flag name and the name of your application. But here is an example of how to specify more properties for application. So we want that mpeg application be allocated in cluster 0. Remember that we have only one cluster in our system because the system size and cluster size are equal. If you have more cluster, we also can specify more a different cluster number, but in this case we have only cluster 0. We want that mpeg application starts at time of 15 milliseconds, so this is the millisecond, and we want that 2 mpeg applications that are described two MPEG tasks that are described here be statically mapped in specific cores. So start, that is the first pipeline MPEG task, will be mapped at core 2x2, and print, the last one, will be mapped at core 2x0. Before simulation we need to compile the application, so let's return to the terminal here and let's compile. Memphis app, that is the command to compile. You pass your test case file, not the test case folder, and the name of the application. Remember that this script here will first look for the application folder inside test case folder, and if no application is found there, it will search inside the root application folder of Memphis. Let me see this error here. I know this error here is because a command in Python installation part is missing, and it's necessary to install graphical feature of Python. So let's try sudo apt. I will update the tutorial with this command, and this problem will suppose not happen anymore. Okay, let's compile the prod-cons. Okay, so the application was compiled successfully. You can see here it is 2 messages. Now let's compile MPEG. MPEG was also successfully compiled. If you prefer, you can pass all applications here using this command Memphis app, your test case, this argument here, .all, all, and the scenario. Now let's advance to the last part of this tutorial, which is the simulation of Memphis. So the last command in this tutorial is Memphis run, and this command accepts 3 arguments. The first one is the Memphis test case, is the my test case file. The second one is the scenario, and the last one is the simulation time in milliseconds. So let's execute. Memphis run my test case my scenario and the time in simulation time in milliseconds. So the simulation starts, as you can see here, and pressing the play button you can see that there is a communication here. If you open the mapping overview, we can see the task mapped, that is prod-cons, and here is the simulation time, and now the MPEG application will be mapped because the time of 15 milliseconds already passed. And as you can see here, in the mapping, the start and print application tasks are mapped in processor 2.2 and print 2.0, and here we can confirm that start was mapped in processor 2.2, address 2.2, and print in address 2.0. Here basically I will explain the basic steps to use it. So the debugging can be called, let me close all this can be called independently. By default it is called when the simulation starts, but you can call the debug independently. So Memphis debugger, and you pass the scenario folder. So my test case, my scenario. So this will open the debugging for this specific scenario. Okay. Here is the main window. You can see here the Many-core that we defined in my test case. So this is a 9-core, a multi-core, a Many-core with 9 core. And after press the play button, this play button starts to read a log file generated by the simulation and it display graphically the communication between the processors. We also can adjust the velocity of this graphical representation, and here are other useful information, but that we will not be explaining now. So let's start. You can see here some protocol executing, management protocol, and now if you go to the task mapping overview, I just will pause. If you go to the task mapping overview, you can see that there is two tasks here that are related to prod-cons application that we developed, and they are communicating. And here are unused cores, but I stopped it at the time of 15 milliseconds, and after this time the MPEG application, as you can remember here, let me open this scenario, my scenario. At 15 milliseconds the MPEG request to be executed, so the system start to admit the application, MPEG application 15 milliseconds, and at this time here 15.2 milliseconds EDCT task was already mapped. I can also advance the debugging step by step. Let me set this as always on top. And you can see here that at the exact moment that the system is mapping the MPEG tasks. So you can see here in green the MPEG application. And if you advance, now we have two communications, the prod-cons and the MPEG communication. One last additional feature of this debugging that I will explain now is about how to see log files. Each kernel running inside each core generates a log file, and you can simply check what is inside this log file by clicking above any core and clicking in log tab and open update. You can see the log of this core. This log is generated by the kernel and also the application running in this kernel. So this is the end of this video tutorial. I hope that you enjoy it, and any question please contact me by the email that is in the website. Thank you for your attention. Bye.